So this is question 15, part C. So we need to now use the graph to estimate the acceleration at t equals 7 seconds. So what we need is the graph back. So we need to see the graph again, which I've cut out and popped there for you over the other question. And what we need to do is estimate the acceleration. So what that means is we need to work out the gradient of the tangent to the curve. Right, now the tangent to the curve is going to be, you're going to draw a straight line at 0.7, and we worked that out to be 14.5 earlier in the first part of the question. So at the coordinate 7, 14.5, you need to put a little cross and then attempt to draw a tangent to this curve, right? Now I've done that with a straight line, and I've just marked the point where I've done it there. What we have to do is work out the gradient of this, and that will give us the acceleration. That's how you calculate or estimate an acceleration. Now obviously it says estimate, and we're going to have a range of different answers we could have and be correct. Mine's going to be different to yours because you're going to have a different tangent drawn. So if you get anything between a particular range of answers, you're going to be fine. And what we can do here is to calculate the gradient of a tangent to a curve is just calculating the gradient of this straight line. And to do that, you do the difference in the y values, or in this case the v values, and divide that by the difference in the x values, in this case the t values. So I'm going to write down what you would do in order to calculate that gradient. So gradient equals the difference in v, in the v-axis values, divided by the difference in t-axis values. And you should see that my line's crossing through at 10.27, so that's going to be a difference of 27 on this v here because it starts at 0. We've got 27 there. And then this difference between 10 and 3.5-ish, yeah, 3.246 maybe. So I'm going to say that's 6.4. Okay, just to be as accurate as you possibly can be with your particular values. Now you've got 27 divided by 6.4, so the gradient is equal to 27 divided by 6.4, and that is just going to be our answer. That's going to be the estimate to the acceleration for acceleration. So get your calculator, and 27 divided by 6.4 is equal to 4.21875, 4.21875. And we can say that that is our answer. I'm just going to round that off for my answer to 4.2 to 1 decimal place, and there's our full, most accurate answer. But it is an estimate, so 4.2 will do for 3 marks. And then the next question is covered over at the moment with the workings on this graph here. So I'm going to get rid of that. That disappears. And what I want to do is get rid of that as well, because we don't want that there. And now we can have a look at working out the answer to D. So D is the speed of this car is directly proportional to the square of the time. We need to find a formula that links V and T. So when we see these questions directly proportional, we have to think about the constant of proportionality, which is represented by the letter K. Excuse me, that was a K if you didn't hear that, and I drew that there. So that's the constant of proportionality. So there's a nice little statement that's written. We can write that in maths speak by using the letters and the symbol of proportionality. So the speed of the car is directly proportional to, so the speed was v, remember, from the graph, and that is directly proportional to, so the proportional symbol is this little fish shape, which is really badly drawn here, to t squared, square of t, so t squared. Now you can replace this little proportional symbol with an equals k. So if it's directly proportional, it's an equals k, and then you multiply that by t squared. So there's our formula, right? So what we need to do is work out the value of k by substituting in some numbers from the graph. Now we could just bring that graph back in quickly. right, we should be able to see that we could choose any one of the points that, or any one of the coordinates. We could choose the 7 and the 14.5 that we worked out that coordinate is there, right? That's a little bit less accurate. We're quite clear in that we've got 10 and 30. So the coordinate 10, 30 is the one I'm going to use. So the value of t is going to be 10 and the value of v is going to be 30. Just get rid of the graph again. So I'm going to write down t is 10 for my calculation, my substitution bit here, and v is going to be 30. Because we know that is what we've been using so far. Now I'll substitute those values in, and t squared is going to be 100 and v is 30. So 30 equals 100 times by k, 100k. Okay? And what you then do is you divide both sides by 100 to get k on its own. So you're going to get 30 divided by 100 is 0.3. You could use your calculator if you want, but it's pretty simple. There you go. There's our answer to what k is. All you have to do is substitute that now back into this part here, and that's going to be our formula that links v and t. We found the constant of proportionality, and it is 0.3. So v is equal to 0.3, and that is t squared. That's our answer. So v equals 0.3, you could use a fraction if you wanted to, t squared, for 3 marks. Part E, Georgina says that the graph shows that the speed of the car will continue to increase after 10 seconds. Make one comment to show that this statement is incorrect. Well, immediately after the 10 seconds, she's correct, isn't she? It's going to keep getting quicker. But eventually, at some point, you'd imagine that the car will start to level out in its speed, because that's what cars tend to do. I've never seen a car just continually get quicker until something incredible happens. Yeah, so at some point the car is actually going to start to level out its speed and then eventually decrease again, because it can't just keep getting faster. So a statement to that effect would be sufficient. So the car will eventually start to level out in speed and then slow down. Try and write neater than what I'm doing. And we could show that, couldn't we? We've got the formula that links v and t. So if we were to say, let's say after 60 seconds, 60 squared, let's just do a little quick calculation. All right, so 60 squared is 3,600. Multiply that by 0.3. Speed of the car is that, and that's not realistic, is it? So yeah, it's not going to keep getting quicker and quicker and quicker. So it's actually not directly proportional to the square of the time. That's a bit of a strange one. But there we go. It's yeah, for that particular graph it was. Okay, that's our answer.